My presentation today will be about something that is much more fundamental than what everyone else is presenting, but at the same time, it might be even grander than some other topic. So, my topic is on the fundamental nature of mass itself, why it exists, and whether or not it is real. So, mass, as far as we have understood it so far, is something that is a measure of the quantity of stuff in objects. However, as we go further and further into the quantum mystery of the universe, this fact seems to be shaky at best. Because as we measure in infinitesimally small scales and with infinitesimally greater precision as time goes on, we can determine that the energy of a system is not merely a sum of its parts. So, what is mass exactly? Mass, as far as we understand currently, is not a measure of stuff itself, but the magnitude of the interaction between that stuff on a quantum level, specifically quantum field interactions. So, when we talk about mass being converted into energy, is that a wrong statement? Well, technically speaking, yes. It's just a whole lot of potential energy and other kinds of energy being converted into one another. A simple example of that would be a hydrogen atom. Now, from the energy mass principle, we know E is equal to mc squared. A hydrogen atom is one of the simplest combination of any fundamental particles in the universe. It is one electron and one proton. The hydrogen atom in its full form with one electron and one proton is less in mass than the sum of an electron and a proton. Why is that? And the answer is potential energy can be negative. And how is that? Potential energy can be negative because when we consider the isolated electron and proton as zero potential, when they come close to each other, they drop in potential because they are now coming into a more stable configuration between themselves. So the potential energy falls below zero, which is why, as I discussed before, mass is literally a measure of energy, not quantity of matter. Because it goes below zero, it subtracts from the total mass of what would have been its total mass should this not be the case. Now, on that topic, why did we get it wrong for so long? Because the discrepancy is so infinitesimally small that until we could have made these incredibly precise measurements, we could not tell the difference as we can see here. Now, from this diagram, you can also see that these energies can be kinetic, potential, thermal, any kind of energy. Another great example from this is a simple spring, something that we can observe daily. A fully compressed spring is actually heavier than an uncompressed spring by this magnitude. However, because of its extremely small magnitude, we cannot observe it unless we do it extremely precisely, which we can now with today's technology. I was planning on doing a longer presentation about where does the mass come from on fundamental particles themselves, not just their interactions. Well, I will do it in one word because time is not on my side today, which is the Higgs field and the Higgs field interaction between the particles themselves. This was the thing that I was going to explain, but as time is not on our side, so I will leave that for another day. Yes.
Okay, so based on what you just talked about right now,
Yes.
How would you explain dark matter and dark energy?
Dark matter and dark energy is actually one of the things that this quantum field theory strives to explain as time goes on, because the fundamental model of particles that we know is not complete. The calculations show that there are incompletions. One of the examples is the infinity condition in the Schwarzschild radius. What was the Schwarzschild radius? The calculations that lead up to the calculations of that radius is actually not something that is a proof of something. It is a proof of the ridiculousness of the calculations, which means that something is either missing or a base assumption of those calculations needs to be tweaked somewhere.
Don't you think it's not just something that's missing, it's a lot of something
that is possible?
Right.
Very
You're
possible.
now thinking about the negative potential.
Negative potential, yes. Negative potential directly relates to the decrease in mass of something that would have otherwise related in something else.
Okay, now very small question again.
Yes, sir.
Speaking of dark matter, if it has like some sort of mass, why can't we see it? All mass we know is visible.
We know is visible. It was actually going to be something that would have come from my explanation of the Higgs field. The matter that we know that has its mass, it's given to it by the Higgs field. It is not an intrinsic property of an electron, quark, or proton, or any of it. How that happens is the interaction of that field with the Higgs field, and that interaction and the magnitude of that interaction is what gives that particle the mass and the magnitude of that mass. Because in four-dimensional space, the velocity of every particle is c, electrons and protons included. However, due to the oscillations in the Higgs field of those electrons and protons, that fourth dimensional velocity is constrained to the third dimension, which we observe as mass. Photons and every massless particle does not interact with the Higgs field, which is why we observe its motion in 3D, which is c, necessarily, because it does not interact with the Higgs field, and that velocity in the fourth dimension is constrained to it. Energy in the fourth dimension is constrained to it. थोड़ा सा flip कर दिया, लेकिन you get the gist.
Nice. There is no such thing as mass. सब कुछ energy है. आप ये कह रहे हैं. वैसे मैं बात को अगर mass जैसी कोई quantity exist नहीं करती ना, तो मैं शायद सबसे पतला तरीके इंसान.
नहीं, मैं ये नहीं कह रहा कि mass exist नहीं करती. मैं कह रहा हूँ हम mass
energy ज़्यादा है.
हम mass को misunderstand कर रहे हैं. Mass is not a measure of the quantity of things. It is a measure of the magnitude of interaction between. और वो इंटरेक्शन सबसे ज्यादा जो इंटेंस इंटरेक्शन हम ऑब्जर्व करते हैं वो प्रोटॉन के अंदर होता है, क्वार्क्स के दरमियान.
ये भी तो कह सकते हैं कि हम एनर्जी को मिसअंडरस्टैंड. फॉर एग्जांपल लाइट एनर्जी हमें पता है. हम ये कह सकते हैं कि लाइट कैरीज मास.
यस, इट डज. ये एक एग्जांपल थी. उसके साथ में अगर हम एक बॉक्स रखें, उसके अंदर फ्लैश लाइट हम ऑन करें, बॉक्स के बाहर हम वो फ्लैश लाइट ऑन करेंगे, वो लाइट एनर्जी रिलीज कर रहा है, उसकी एनर्जी डिक्रीज कर रही है, एंड इट डिक्रीजेस इन मास एज अ रिजल्ट बाय द सेम मैग्नीट्यूड दैट वाज शोन इन लेकिन अगर हम उसके इर्द एक बॉक्स रख दें और वो लाइट को हम बाउंस एस्केप ना करने दें, तो वो मास चेंज नहीं होगा उस पूरे सिस्टम का ऑब्जर्व. मास डज कैरी लाइट डज कैरी मास इन दिस सेंस.
Thank you.